Hi everyone, welcome to my channel Concept Learning. This is Rasagna. So, in my previous video, I have introduced you all to 3D geometry, right? So, in that class, I have told the concepts of 3D geometry, like the basics of 3D geometry. That is, I have told the section formula, and I have also told the distance between 2 points, etc. And I have also discussed about direction cosines and direction ratios, right? So if you have not watched my previous video, I have provided the link in the description box below. You can check in that. So in this video, I am going to start with another new topic in 3D geometry which is not found for you in 2D geometry. Okay. So the new concept is about planes. Okay. These are 3D planes. So actually what are these 3D planes? I will tell you. A plane is something like a board, a book, or something like that. Okay, so if I want to represent it on a board, I will do it like this. On a board, it looks for you like a rectangle, but it is not so. It is like a book, paper, or anything, any plane. Okay, so actually, this 3D plane is something that is found in the space. Okay, so the general form of this plane is ax plus by plus cz plus d is equals to 0. This is called the general form of the plane, 3D plane. Okay. So now how do we write the equation of the plane? Yeah, it is similar to the equation of the line. So generally in 2D geometry, how do we write the equation of the line? We write it as ax plus by plus c is equals to 0, right? But in equation of the plane in 3D geometry, we add another term that is cz plus d, the other constant. Okay. So we have many methods to find the equation of the line in 2D geometry, right? So in the same way, we also have different methods to find the equation of the plane in 3D geometry. So let us look all those methods. Okay. So guys, the first method to find the equation of the plane, it's a very familiar method. Okay. It's also very easy. So it is like the general form. Okay. I'll tell it. It is a of x minus x1 plus b of y minus y1 plus c of z minus z1 is equals to 0. So this is the general form, okay, of one method. Okay. So now what are these x1, y1, z1 and these a, b, c? What are these? Now I'll explain you all these terms. Okay. So if there is a plane, the required plane, if this is the required plane and there is some point x1 comma y1 comma z1 in this plane. Okay. So I'll put it over here, x1 comma y1 comma z1. So this is a point on the plane. Okay. So these are the x1, y1 and z1. Now what are these a, b, c? So what are these a, b, c is? These are the direction ratios of normal of the plane. Now what is that? Actually what is normal? Normal is a line perpendicular line, right? So normal to the plane means the perpendicular line, the line which is perpendicular to the normal, right? So if this is the plane, I will draw a line perpendicular to this, perpendicular to the plane. So this will be the normal. Okay. So the A, B, C are the DRs of that normal. Remember, of that normal line, not the plane. I have also told you in my first class that only a line contains DRs but not a plane. Only line contains DRs. So the DRs that we take, that is A, B, C, are the DRs of the normal of the plane. Okay, normal of the plane. So those are the A, B, C's. And the x1, y1, z1 is a point. So now if they give you any plane's normal DRs and a point, then you will use this form to find the equation of the plane. Okay. So guys, now I am going to tell you the 3-point form. Now previously I have told you the formula of 1 point form, right? That is, if you have got 1 point on a plane and the pair of DRs of one normal. Now you don't have any sort of DRs now. You have only 3 points on a plane. That is, if this is a plane and we have 3 points, that too the 3 points are non-collinear. Remember, the 3 points are non-collinear, not collinear. So if there is a point x1 comma y1 comma z1 and another point x2 comma y2 comma z2 and another point x3 comma y3 comma z3. If there are 3 such non-collinear points, then what would you do to find the equation of a plane, of the required plane? So there's a small formula for that. That is det of x minus x1, y minus y1, z minus z1. Again, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. That is equals to 0. So this is the formula for the equation of the plane if you have been given 3 points situated on a plane. 3 points situated on a plane, that too non-collinear points. Okay. Now let's discuss another form, that is intercept form. Now let us speak about the intercept form. Okay. So now what is this intercept form? Generally in 2D geometry you have already studied the intercept form of a line, right? So have you remembered that intercept form of a line? Even in first year you will be studying that. That is, if this is a line, the intercept form of this line is x by a plus y by b is equals to 1. This is called the intercept form of a 2D line, right? Now what do we want? We want the equation of a plane, intercept form of a plane. So now what is that? That is also quite simple. Just as this, but we add just another term. That is, the equation of this plane is x by a plus y by b plus z by c is equals to 1. This is known as the intercept form of a plane. It is just same as the line, but we will just add z by c because it is 3D geometry. In many cases we just add the z term. We will do it same as in 3D, but we will add the z term in many cases. Now we will look at more such similar cases. What are those cases? Now the first thing is, how do you find the distance between the perpendicular distance between a point and a plane? If there is a point given and there is another plane given, okay, now you want the perpendicular distance from this point to the plane, okay, perpendicular distance from here to the point, okay. Now what do you do for this? In 2D geometry you have already studied about the distance of the perpendicular distance of a point to a line. What is it? Have you remember? I will tell it. That is, from a line to the point, the perpendicular distance is ax1. This point is x1 comma y1. So ax1 plus by1 plus c by root of a square plus b square. If ax plus by plus c is equals to 0 is the equation of this line, right? Am I right? So now in the similar way, for the plane, what is the distance? How do we write it? So I have given you that the equation of this plane is ax plus by plus cz plus d is equals to 0. This is the given plane equation. Okay. Now I will tell about the point. The point is x1 comma y1 comma z1. This is the point given. Now what is the formula for the distance of the point to the plane, the perpendicular distance. Remember the perpendicular distance. Now what is it? There's a formula for this, that is mod of ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square. This is the formula for the perpendicular distance of a point to the plane. Okay, is it clear for you? Now, this is also very similar to the 2D geometry concept. Now, I'll tell you another concept which is similar to the 2D geometry concept. That is distance between two parallel planes. Okay, you have already studied about the distance between two parallel lines. That is, if you have two parallel lines, those lines are ax plus by plus c1 equals to 0, and the other line is ax plus by plus c2 equals to 0. Then how do you find the distance between these two parallel lines? You have one formula, do you remember? Yeah, that is c1 minus c2 by root of a square plus b square. Is this the formula? So the same thing we are going to do in case of planes. But as you know, we are going to add another term. So let us look what that is now. If there are two parallel planes, if the equation of this plane is ax plus by plus cz plus d1 is equals to 0, and another plane parallel to this is ax plus by plus cz plus d2 is equals to 0. Now, how do you find the distance between these two planes? Parallel planes. So, you have the same formula, that is here d1 minus d2, because the constants are d2 and d1, right? So, mod of d1 minus d2 by root of a square plus b square plus c square. The same formula. What have we added? Another term over here, right? So this is also the same formula. So guys, now we have discussed many concepts, right? And now we are going to learn another concept, that is nothing but the angle between two planes. Now what is that angle between two planes? I am going to tell you now. If there are two planes given for you, if this is one plane, if this is a plane and there's another plane that is given to you. If these two planes are given to you and you are asked to find the angle between these two planes. Now how do you find that? There's a small method for this. Let us look at it quickly. If this is the normal that is perpendicular to this plane, the normal of this plane, sorry, and if this is the normal of this plane. Now, the angle between these two normals will be the angle between the two planes. Okay. Now, how do you find that angle? There's a small formula for that too. Okay. So, we'll know. If the drs of the normal of this normal is a1 comma b1 comma c1, and the drs of this normal is a2 comma b2 comma c2. Okay, we have been given the drs of the normals. Okay, so now the angle between the two planes is a small formula, you need to remember it, that is cos theta. Theta is this angle. Okay, theta is this angle. So cos theta is equals to a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Okay, have you understood the formula? So this is the formula to find the angle between the two planes. Now what are these? drs of the normals of the planes. Okay, got it? Now listen very carefully. If this part is equals to 0, if this part is equals to 0, what will happen? This cos theta will be equals to 0. Am I right? So, what is the value of theta? If cos theta is equals to 0, theta value will be 90 degrees. Right? That means perpendicular. Okay, that means perpendicular. Theta is 90 degrees. That means the normals are perpendicular. That means the planes are perpendicular. So, remember very carefully, children. That is, if the two planes are perpendicular, the perpendicular condition that we use is A1, A2 plus B1, B2 plus C1, C2 equals to 0. That is, the dot product of the drs of the normals of the planes is equals to 0 if the two planes are perpendicular to each other. Okay? Have you got it? Well, so now let us look at another topic. That is, we have already discussed about the concept when a plane is having 3 points. Okay, plane consists of 3 points, and if we want to know the equation of the plane, right? So, what do we do for that? To know what do? We use one small formula, that is det of x minus x1, y minus y1. You know that formula, I have already told you previously. So now there is another thing, that is, if there is a plane, okay, and you have been given 2 points on a plane. One is x1 comma y1 comma z1, and the other point is x2 comma y2 comma z2. Got it? These are the 2 points, and you have been given some other thing, that is there is a line situated on the plane, and you have been given the drs of the line. Remember, not the point, drs of the line. That is L comma M comma N. Okay. Now you need to find the equation of this plane. Then what are you going to do? It's simple, children. Even the 3-point form comes in the same method, but you have got some formula. For this also there is a method and a formula. First I am going to tell you the method, and I will tell you the formula later. Okay. So now what are you going to do is, you are going to take one perpendicular line that is normal to the plane. Let the drs of that normal be, let them be A comma B comma C. Okay. Now if this is normal and this is passing through the plane, these two lines will also be perpendicular, right? Then the dot product of these two will be 0. Okay. Have you remembered the previous concept I have told you? I am using that now. So that is LA plus MB plus NC is equals to 0. Got it? So now, if there are other 2 points, right? If I join them, I will also get another line, right? If I join these 2 points, I will get another line. Okay. And now, remember, previously I have told you what drs are, right? So, if there is one plane, okay, and there are 2 points on the plane, x1 comma y1 comma z1 and x2 comma y2 comma z2. Okay. Now if you want to find the drs of this line joining these 2 points, you have a very small formula, that is x2 minus x1 comma y2 minus y1 comma z2 minus z1. This will be the drs of that line. Drs of the line passing through the point x1, y1, z1, x2, y2, z2. Okay. This is a small simple formula. You can remember it very easily. So now we will use it over here. If this is a line formed using x1, y1, z1 and x2, y2, z2, these will be the DRs, right? So I once again do the same thing. That is, I will take a normal, okay, and then also I will have A, B, C as a normal DRs. I will use the perpendicular condition once again and I will get another equation like this. Okay, then I will solve those two equations. Okay, then I will get A, B, C. After I get A, B, C, those are the DRs. Then I will use the simple formula, that is A, first 1 point form. I have told you the first one. X minus x1 plus b into y minus y1 plus c into z minus z1. So I am going to repeat the process once again. Listen very carefully. That is, if you have been given 2 points on a plane and the DRs of one line through the plane, then how do you find the equation of the plane? You will take one normal which has DRs A, B, C, and you will write the perpendicular condition. That is, dot product is equals to 0. Okay. Now, there are 2 points, right? So, I will join those 2 points and I will get the DRs of that line by using x minus x1, y2 minus y1, z2 minus z1. Okay. Now, I will take these DRs and once again the perpendicular line DRs A, comma B, comma C. Okay. Then I will get another perpendicular condition like this. Then I will solve those two equations to get A, comma B, comma C. Okay. After I get A, comma B, comma C, I will put A, B, C in these places and x1, y1, z1, I will take this point. Then I will get the equation of the plane. Simple. So, this is very lengthy process, right, for you to do. Then you can use some simple formula in your JEE Main, Advanced and these competitive exams. You cannot waste your time doing all this big process, right? So, there's a very small formula which you can remember very easily. It will be similar to the 3-point form. Okay, very simple to remember. That is, that of x minus x1, you have 2 points, right? The plane and the 2 points x1 comma y1 comma z1 and another point x2 comma y2 comma z2, and there's a line with DRs L comma M comma N. Okay, now x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and the last row, instead of the third point, we are going to keep this DRs. Okay, that is L, M and N. Simple, very simple. Good. Now I am going to tell you some other one that is also very simple. I am going to directly tell you the formula, because for that also you can do the same thing as the long process that we did now. You can do that also. Okay. Now what is that is, if I have 1 point on the plane, if only 1 point is given on the plane, that is x1 comma y1 comma z1, only 1 point is given, remember, and we have DRs of 2 lines through the plane. Okay, one is L1 comma M1 comma N1 and the other is L2 comma M2 comma N2. Clear? You have been given the DRs of the 2 lines through the plane and 1 point on the plane. So now what do you do to find the equation of the plane? Is very simple. That is also x minus x1, y minus y1, z minus z1, L1 M1 N1, L2 M2 N2, that is equals to 0. Simple, very simple. If you want, you can also use that long method I have told you previously by taking the normal and all that. Okay, so I have covered most of the concepts of the planes, 3D planes. Okay, if I have missed any concept, I'll definitely clear those concepts in my next class. Okay, so in next class I am going to teach you about the lines and the connection of lines with planes. Okay, bye for now. Meet you in my next class. Bye bye.